let's begin with a brief explanation on how the sparse firing mode works on the OmniScan X3. In a typical TFM inspection, we utilize FMC, or full matrix capture, as the means of pulsing and receiving signals from a phased array transducer. And one of the questions that we often get with the sparse mode is this a form of HMC, or half matrix capture? And the answer to that is no. So in a typical FMC process, we fire one element of the transducer and we receive with everything. In a half matrix capture mode, you begin by pulsing one element of the phased array probe and then receiving with all elements of that transducer. So on the left-hand side here, we have our half matrix capture setup with a transducer that has 5 elements in the transducer. And we'll go ahead and pulse number 1 and receive with elements 1, 2, 3, 4, 5, all from the phased array transducer. And let's highlight those green to simulate that we've received on those elements. In a half matrix process, each time you pulse the element next within the sequence, you reduce the reception element that's already been pulsed. And what that does is it reduces the amount of sound waves that are being received, thus reducing the amount of data that's being fed to your acquisition software or to the instrument. So what this ends up looking like is as we pulse each element, we drop off a receiving element. Thus, you get half of the data set. And this process works fairly well when you are attempting to send the raw data to another device. But in an instrument like the X3, where we are summating all of the data through the hardware of the unit, a better way to improve upon the inspection speeds is to, instead of reducing the amount of received elements, is to actually reduce the amount of pulse elements. So in the sparse firing technique, what we do is we can program the instrument to reduce that number and fire, say, every other element or every other 2 elements or at certain intervals to speed up the process. So in the sparse mode on our right-hand side, we might reduce that by a factor of 2. So let's say, for example, we start with element number 1 and that pulses, and we'll highlight these cells to simulate that we've received on that pulse. In the next sequence, normally we would fire element number 2, but in this case, in sparse mode, we choose to skip the pulsing of element 2 and go straight to element number 3. So then we pulse with element number 3, listen with all of the other elements of the transducer, and there we have our next data set. And then we repeat that process until we reach the end of the transducer. So by firing less elements of the transducer, that also creates less data for the instrument to have to manage, and that should give you a boost in the inspection speed. So in the next part here, what we'll do is we'll set up our OmniScan X3 and take you through the process of setting up the sparse mode and adjusting it for an actual live inspection. Now that we've gone through a brief explanation on how the sparse mode works on the OmniScan X3, let's go through the practical application of it utilizing an actual inspection. What we have before us here is a 1-inch thick double V weld, and you can see the setup for that here directly on the OmniScan X3 screen. So we've programmed in the joint configuration, wall thickness, and we've also programmed in our 5 megahertz 64 element transducer. This transducer is currently running 2 separate TFM groups, a 4T group to cover more of the upper half of this component, and a 2T group to cover more of the lower half of this component. So we'll go ahead and compile this together and run through an encoded inspection to see what no sparse running a full FMC data collection set looks like. So on the left-hand side of the screen here, we have the 2T display running on the top. On the bottom, we have the 4T display running here. So you can see both sets of data being collected at the same time, and we'll go ahead and run this inspection. I've got a mini wheel encoder attached to the 5L64 transducer to act as our recording device for the data. So we'll position the transducer onto our part in accordance with our scan plan. Press the play button to initiate the acquisition, and we'll start collecting data. Now what you can see as I begin rolling the transducer here is that we get a output of the scan speed at the top of the screen. You can see here this green icon here spells out for us what our acquisition rate is currently, which is at this point 11 millimeters per second. And what that means is my max speed right now as I pull the transducer down the component is 11 millimeters per second, or roughly about a ½ inch per second. And that makes it a little bit difficult to pull the transducer without missing lines of data. As I pull here, if I move too quickly, you can see that that green light flashes red, indicating that I've missed data during this data collection. And you'll also notice on the two top views on the left-hand side of the screen, there starts to appear black lines of missing data. So I've got two issues here with this particular setup in running the full FMC data collection. And that is my slow scan speed. So you can see here just how slow it takes me to run the acquisition. And then the propensity to miss data lines. So what we'll do now is activate the sparse setting and just kind of compare and contrast what that looks like. In our TFM settings, under our pulsar configuration is where we find our sparse mode. Obviously right now it's running full matrix, but we do have the flexibility to apply different levels of sparse firing. 1x2, 1x3, 1x4, 8, and 16. And again, going back to what we talked about earlier, this will skip whatever number of elements that you see in the selection here. So if we have this set to say 1x3, this means it'll skip 2 elements and fire every third element of the transducer. And ideally what this is going to do is give us an increase in the acquisition rate for the system. You can see there as soon as it finishes adjusting that to the 1x3 sparse, we get a significant increase in our acquisition rate. So now rather than collecting at 11 millimeters per second, we are now collecting at 31 millimeters per second, which is a significant jump. So we'll add a little bit more couplant here just to make sure we're coupled well. I'll go ahead and reset my acquisition here on the unit. Realign my transducer and just kind of get a visual comparison on what kind of increase we see in the scan rate. So you can see now, if we keep our eye on the green button up at the top, obviously we still may miss data lines, but not as frequently as we did before, and this gives us the ability to collect our data at a much faster rate. And this is collecting data using a 64-element transducer and running 2 full groups of TFM inspection. So that works quite well there. We can pause the acquisition and go through the process of analyzing our data on the unit. But just that little bump in acquisition rate equals to a larger increase in the productivity of your inspections. If you can collect the data faster, then that's the faster that you can get into analysis and then conduct your reporting out to your customers.